Hello. Okay, I think it's working now. So today's problem is a scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measures 24,000 bacteria. Assuming exponential growth, the formula P equals C2 to the RT gives the number of bacteria in the growth medium, where R and C are constants and P is the number of bacteria T hours after the initial measurement. What is the value of R? So, um, this is an exponential function modeling problem, and I'm going to show you how to do it by hand, and I'm going to show you how to do it with Desmos. I think either way is fine for this. I think this is a relatively quick problem if you understand how to use the exponential model, but if you don't, uh, in this case, Desmos is a good shortcut. Not really a shortcut. It takes about the same amount of time. So let's take our data. We got 12,000 bacteria. 4 hours later, this is initially 12,000. 4 hours later, 24,000. And here's the model. So if I put this in like a data sheet, I would put like initially is code for time equals 0. So time 0 corresponds to 12,000 bacteria. And 4 hours later, there's 24,000 bacteria. And bacteria, we don't know what we're going to call it yet, but assuming exponential growth, the formula P equals C2 to the RT gives the number of bacteria in the growth medium, where R and C are constant, and P is the number of bacteria. Oh, so this is the number of bacteria here. So the number of bacteria is P, and T, it appears there, right? So if I was to do this by hand, I would just do algebra. They gave me some information here. I'm going to plug it into the equation, and then I'm going to solve for what's left. So first I'm going to put in 0 for T and 12,000 for P. So that would give me 12,000 for P equals C times 2 to the R times 0. And then the other equation, I would put in time equals 4 and C equals 24,000. That would be 24,000 equals C to the 2 to the R times 4. And first I would do this one, because look how easy this is. If I have a 0 here, multiplies times R gives me 0, and 2 to the 0, that is, of course, 1, because anything to the 0 is 1. So that basically tells me that 12,000 is C. So C is 12,000. I already know that C is 12,000. Now, they're asking me for R, not for C. C is always 12,000 because it's a constant, right? These are the two variables. C and R are constants. I'm going to put 12,000 into my C value here. So then I have 24,000 equals 12,000 times 2 to the 4R. And let me scroll down so I have a little bit more space here. So I have 24,000 equals 12,000 times 2 to the 4R. And I can cancel some stuff out. I can cancel out the case. I could divide both sides by 12. I would end up with 24 divided by 12, which is 2. So 2 equals 2 to the 4R. So I guess this is 2 to the 1, this is 2 to the 4R, so that means 1 has to equal 4R, right? R equals 1/4. And I think that was one of the choices. It would be B, right? Okay, so that was doing it by hand. Doing it with Desmos. So Desmos, remember, we can do modeling problems by using the modeling function on Desmos. The way the modeling function works is you put in your data sheet, except you can't put it in as T and P. You got to put it in as X and Y. So I'm going to put it in as X and Y. and then I'm going to model it by putting in this function here, except I can't put in P and C. I need to put X and Y. So I need to, or I can't put P and T. I need to put X and Y. So I'm going to put Y equals C to the 2R to the X, okay? Now, when I type this data sheet into Desmos, it's going to automatically think that this is points to model with its modeling function, and so it's going to like automatically index this data with some subscripts. And so the first data set you put in is going to become X subscript 1, Y subscript 1. The second data set you're going to put in is going to become X2, Y2. So if you want to model with X1, Y1, you need to tell Desmos that by putting Y1, X1 here. And then instead of the equal sign, you're going to tell Desmos you want to model by putting in a tilde. Okay, so let's type this data into Desmos. So I'm going to put plus, put table, and then I'm going to put 0 and 4 in for x1. And then I'm going to put 12,000, and I'm going to put 24,000 in for y1. And then I'm going to type in this function here, y1. I just type in y1, and it automatically knows it's subscript 1. Then I put tilde, which is I can do with the tilde key, or I can go down to the keyboard and go to ABC, and I can press the tilde right here. Okay. No, it did a weird symbol there. Did this a mathematical symbol for, I think it's approximately. So I'm going to put in now capital C 2 and then superscript RX1. When I did superscript, I could do the caret symbol. I could go like that on the keyboard, or I could just go to the keyboard, and I think that there's like, oh, there's this here, this exponential here. Okay, so I typed that in, and so now it already modeled it. It already modeled it, and it already gave me the value for the best value for capital C is 12,000, and the best value for little r is 0.25. By doing that, it perfectly matches the function. You can see by saying r squared equals 1 and r equals 1. So the answer would be 0.25, which of course is also 1/4, which gives me the same answer, right? If I wanted to see this in a graph, notice that like no matter how much I zoom out, it's like really hard to see it, and I can barely see the graph. If you want to see values on the graph without zooming out, let's say that I want to know when does this model cross the y-axis. I can see that by changing the grid to if I go to more options, I can change the scale to log. The most important scale to change is the y-axis, because the y-axis is the one that has huge numbers. The x-axis has pretty small numbers. So if I do that, then I don't need to zoom out very far. I can already see that the y-intercept is 12,000, which is the point that I saw. Now you can see without zooming too much that the function that I've modeled here goes perfectly through those 2 points. And it doesn't look like an exponential function because I have changed the y-axis to the log scale, but that's okay. Now, do you need to look at the grid for this? No, because it already perfectly modeled it without you even looking at the graph. I'm just giving you a little bit more information about how you can maybe do other problems where you need to intersect or something like that. Okay, that's it. Bye.